student in a private school can use AI, can use, and also this web can do many interesting this kind of a project. Okay, so I think we need to go this chapter. So last time we briefly mentioned about the green building. So the green building is I think in somehow is related to some initiative globally, right? Of course in Hong Kong, of course we mentioned green building is somehow has different kind of definition and sometimes misleading, right? So that we just show green building is not simply we have some green, this kind of outlook, right? So that you need to add additional issue, right? So of course the key issue is first is we need to understand why globally how high the government of Hong Kong want to push green building. Do you have any idea why? What's the reason? What's the reason? The key reason is clear. So that the many building, like for Hong Kong, we have a lot of building. Hey, I don't know, do you have some idea how many building? No, Hong Kong government has. I don't know if you have some idea, have how many building? How many building in Hong Kong? Especially in private sector. How many building in Hong Kong? Any idea? After here, it's about 40,000 building. So it's a lot. It's a lot of building in Hong Kong because we have so many people. You see, more than 7 million people living in very small this kind of area. So that in this case, we need to have very building, a lot of kind of a building to accommodate so many people, so many companies, so many apartments. So this something is non-trivial, and then of course building consume a lot of energy. Or building also use a lot of raw material, right, from the earth, right? So in this case, it's quite important to think about this green building, right, from the viewpoint of the global this kind of warming problem. And then of course the Hong Kong government do have signed international agreement to reduce this kind of carbon this kind of emission, doing that. So that this is something there's a pressure from the government side. They want to promote this kind of green building technology. Of course, the government had pressure, and then of course the government has also additional funding. I still remember in the past 2 years, the Hong Kong government has initiative provide some funding to let this kind of maybe some researcher in the university or some industry people to come with this kind of green technology fund. So do you say Hong Kong do have this funding? Do you know how much Hong Kong government provide? Any idea how much money Hong Kong government provide for green this kind of building technology? Any idea? It's not small. Can you guess the number? So that one student say total amount of funding. So one student is say 100,000, another 5 million. Wow, it's many students have different idea. 10 billion, So that actually is around 200 million Hong Kong dollar. 200 million, okay, 200 million Hong Kong dollar for green technology. This for Hong Kong government to promote this kind of green building technology. So it's quite a big number, and then so that of course I told you why. So that this kind of building consume a lot of energy, and so that if you don't try to reduce this kind of thing, and then they do have some problem. So that this is a issue. So that why the government want to provide this kind of money for this kind of thing. This is also government have some special website to promote this thing, and then so that if you have some good idea, and then come with thing, and then so that that's something I tell you, this is the government do have this kind of a green technology fund for see, it's not just for fun. So that you say if you have you're a good engineer, right? Engineer to come with some good design of the green building, or some maybe not the whole building, but selected this kind of as mentioned in previous lecture, we have a building system, right? So if you can focus on some specific this kind of technology, right? For example, like HVAC, air conditioning system to save energy, or you have second one to think about smart window or other things. So that I think sometimes I don't think everybody will work on the building design, but with some specific this kind of direction subsystem, right? Then it should be much more practical for all you to think about this thing, right? As I mentioned, especially in last previous lecture, no, we have a smart this kind of maybe smart lighting, right? Smart HVAC, and then we have many things. Maybe smart this kind of elevator, right? So that this is something in Hong Kong. Elevator is quite important and thing, right? So that as long as you can think about this thing, I can see there's a lot more this kind of thing. Of course, we also mentioned this kind of Amazon Alexa, right? So this is a smart, this kind of loudspeaker, so that to connect with this kind of AI, right? And man's microphone. So all this I think will be man's microphone. So all this can be quite useful, right? Of course, there's another thing with mention, right? So green building also come with additional issue about, can we come with some green material, green material, and then during construction, now you use much less energy and create much less pollution. So all this also will be quite important for us to consider in this kind of green building design. Okay, so that so of course I should also remind you that this coming we have some special set online seminar. If you have chance, I already announced on our campus website, so that you have time, so that you can try to look at this kind of campus website for this special seminar, right? Special I just try to remind you about one special seminar from Tsinghua. There's one professor who had developed some special kind of green construction way for seeing Professor Feng Jing. So that if you have a chance, so that you are welcome to watch this kind of thing. So that again, Cha remind you about this special seminar. Okay, so that it can arrange also online. So if you have no time, you have additional online teachings, and then you may also look at some reference material about how this technology has been used, right? Rock fill concrete technology, and it can really reduce the use of concrete for construction by 70%. I do think this is one part of a green building technology. So that if you chance, I think you are welcome to at least have more idea about this kind of another special seminar and technology, rock fill concrete technology. Definitely is also within the context of this kind of green building area. Okay, and of course, we also mentioned about a green building is you can use less energy, less material, or a green material to build the building. And then another issue is if your building is much more reliable, and then you can last a much long period of time, so that it can also reduce a lot of this kind of waste, right? And so this is also quite important, right? So in general, as we mentioned, so that a green building has a little bit different this kind of focus compared with those smart building, right? So that in this case, still similar to the smart building, we are focused on how can we come with a more economic, cheaper, right? More efficient way to use those kind of resources more general, electricity and resource water and even material, building material, right? And you also focus on this kind of life cycle design and human well-being, right? Well-being, that means if you try to have some building which is, let me see, sorry, if it has building which can also be more healthy, right? That is also quite important. Healthy now and energy efficiency and then also why. So that's why this is also quite important issue. Okay, and so of course here I think in general I think it's very similar. These several topics I would say quite similar to our smart building in previous lecture. Why? But this one a little bit different. Why? That means we will most likely we want to use those kind of more this kind of green material. For example, like what I mentioned, this kind of rock filling, this kind of rock fill concrete. This definitely is have more green material, eco-friendly, right? So that and then of course then you can think about how can we make it sound a little more flexible and design so that then in this case you can this kind of a long-term reliability issue, right? So then of course another aspect is that we want to have this kind of how can we have much more user-friendly for this kind of building engineering, right? So this is for this thing, of course I can say this is probably will be better achieved by using this kind of ICT technology. Why? Those kind of thing is similar to what we mentioned in previous smart building, right? And finally, of course, we can also think about this kind of thing, right? So how this green building can be useful, right, to increase productivity, right? Productivity of the people maybe work in this kind of building for manufacturing, right? Or for some company work, right? The project. Of course, productivity in a school is what? We hope that our school building is need to increase productivity of what? For you, can you have more productivity to study, more efficient study and learning, right? Enhance the learning efficiency, so that that is something quite also a different thing. So that so in this case, but of course, as I mentioned, one of the interesting issue, right? So that how our building can be have more productivity, Do you have an idea how the building can more productivity? This is something in more quantitative way. Do you have some idea? How can we have this kind of enhance this kind of productivity from building engineering you mentioned? Any idea? It's something quite automation, sir. Very good. One student said, Paul Yan mentioned that if you have more automation, then of course, for example, you use this kind of self-driving car or the car to deliver some product, maybe inside the building. While now COVID-19, maybe you cannot, you are in a quarantine. Maybe, can you consider about using the self-driving car to deliver the food? Do you say? So that's something is food delivery, delivery. The kind of self-driving car for you. If I know that someone, if you have to do the quarantine, right, and then so that probably it's difficult seeing, so that to avoid this kind of a virus transmission. I do know that there's some company really use this kind of self-driving car, electric car to deliver this kind of food or package, right? So this is something. But on the other hand, so that there's another interesting thing I just tell you. For the building HVAC system, air conditioning system, we can also increase productivity. I don't. Do you have some idea how the air conditioning system can affect about this kind of productivity inside the building? Any idea? What do you think? Can air conditioning system HVAC have this kind of relate to this kind of productivity? Once we say Hoy what mentioned more comfortable this kind of environment. Of course, that something is say if too hot, then you probably too cold, then you cannot work more efficiently or study more efficiently, right? So that this is more comfortable, and so that that is also quite important. We will have some additional lecture about air conditioning system, and then try to think about this issue, right? So that the comfortable, the how comfortable has some something is not too precise. It's not very precise. Do you understand? We need to. That's why we need to think about more quantitative way describe this kind of human thermal comfort. Do you understand? So that this is something actually they do have some industrial standard from about human thermal comfort or international standard, ISO standard for this thing. Actually, I do have one peer student have done the good job on this kind of how can we come with this kind of micro this kind of human thermal comfort sensor, do you understand? To really quantitatively describe this kind of comfort, right? Human thermal comfort. So this is something in reality actually is a little more complicated. Actually, it's non-trivial. Although the industry and international standard has human thermal comfort, but this kind of human thermal comfort measurement or sensing is actually very expensive. You cannot imagine. Do you know how much? No, if you want to measure the human thermal comfort, right, for a building, at this moment there's no local sensor, so that actually at least my when I my PhD student worked on this kind of micro human thermal comfort sensor, actually we bought this kind of 20,000 Hong Kong dollar, this kind of human thermal comfort instrument to study human thermal comfort, so that we realize this is something is non-trivial. Although the industry and also has certain standard for this human thermal comfort, they call PMV, but still this is, I will mention a little bit more. PMV is predicted mean voltage. It's actually it is one type of human thermal comfort, this kind of index. So there's a long list of different kind of human thermal comfort, this kind of index, right? So that so here PMV is one. Then at least I will give you a little more information, and of course I do have my student also come with some smartphone app for you to think about how to do quantitative way to calculate this human thermal comfort. So this is somehow is non-trivial, but it's critical, as I show you that so that if you cannot have a more quantitative this kind of way to determine the human thermal comfort, and then it's very difficult for you to think about this kind of engineering, right? Come with much better engineering design. So this is something I just tell you. It looks simple, but in reality, it's non-trivial. Actually, let me just quickly show you why. Because I still prefer to give you more quantitative way, right? One student already mentioned, okay, we like this Hoi what mention more comfortable, but how comfortable is comfortable? We are engineer. We need a more precise way doing that to come with things. So let me quickly show you this kind of way. So all of you now can see that many this kind of online platform, and then so that you see it's the human thermal comfort, like you feel comfortable. That's actually much more complicated. You have a temperature, but not only temperature, humidity, and this kind of air velocity. If you have air conditioning system, and then you also have this kind of radiation, right? Radiation, mean rate, okay, and then also this kind of thing, this kind of rate of mechanical work, metabolism, while doing that, and also this kind of clothes condition. Why? If you wear different clothes, and then you different result. So by try to do all this quantitative way, then you can calculate this kind of PMV doing that. So typically PMV, human thermal comfort, is -3 is very cold, +3 is very hot. So that in general, so you can see if you adjust the temperature, for example, like 30 degree, then you calculate again 1. Right? If sometime if it's 35 degree or doing that. So here they give you this kind of very precise way to determine it. So of course, if humidity, you can see 50 in Hong Kong, humidity is another parameter. For example, if in Hong Kong 99%, you see, humidity has also quite big impact on human thermal comfort, right? And PPD is another thing to do, is because when we look at human thermal comfort, what's the problem? What's the problem of this thing? Everybody may be different. Do that. So that in this case, the PMV is empirical model using about 1,000 people. So it's human experiment with different conditions, different temperature, humidity, and many things, and then come with 1,000 this kind of human study, and then come with this nonlinear, this kind of human thermal comfort, this kind of model, right? And then so that in this case, of course, once 1,000 people with same this kind of parameter, definitely some people will feel okay, some people feel don't like, it's not comfortable. So that in this case, so PPD basically is tell you about the certain percentage of people will be happy or not happy about this condition, indoor condition, doing that. So that this give you some quite, you can see they call the predicted percentage of this countries you're not happy, satisfied or not, to say. So this is something, of course, if you come with like 24 degree and then 50, then look again, you see, it's 24 degree. I think this EMSD, but Hong Kong government typically recommend for 24 degree. But the humidity also, you see, in this case, we have a much smaller percentage of people will be not happy about this thing, right? So that thing is one thing. You see, if it range between a plus minus 0.5, typically I would say it's a good design. If you have plus minus this kind of 0.5, why this kind of PMV, and then most likely you feel comfortable. Okay, so here is give you something more quantitative way. And again, this is something related to the HKUST standard. This is a standard. PMV HKUST standard, the American Society of Heating, RA, refrigeration and air conditioning system. Okay, so that this is one of a standard from and then also ISO standard. Okay, industrial standard, I would say. So that but I told you, unfortunately, if you want to measure this kind of PMV, I told you we need to buy more than 20,000 those kind of instrument, right, from Italy. And if you try to get this kind of PMV instrument from Germany is about $40,000 Hong Kong dollars. So it's very expensive. So I do think it's impossible for every building to have this kind of very expensive PMV instrument to look at things. Right? So that's why it's quite important, as I show you, that how can we come with much more low-cost way to look at this kind of human thermal comfort, this issue. So this is something, it looks simple, but in reality, it's non-trivial. I told you, it's something require have a lot more engineering to make become more low-cost way to increase this kind of thing. Okay, anyway, here I just provide some additional information for you to think about this thing. Of course, especially this is something in Hong Kong, without this kind of air conditioning system, especially in summer, I do think it's very difficult for you to survive. Too hot. Think about if we have no air conditioning system. Now, when you study in our classroom, what happened in the summer? What happened? It's too hot, and then that's why this is something have it's quite critical now for the building to have a proper this kind of indoor this kind of environment control, right? And of course, another thing we also mentioned, green building has another quite important thing in general, why? So that we need to understand about first is how can we look at now this kind of you think about this kind of design which can be more sustainable, right? For example, you pick out the right place for the building, right? And then hopefully it can be close to the nature, right? And also it can be also quite, when you do the building engineering, design, manufacturing, and then you will not have big impact and not create big pollution, right? So that and then you'll be also quite create some design, right? If you come with this kind of good design, and then so that in this case it will be much better, right? For this kind of green building and thing. Of course, typically, as I mentioned, like now we are in a very difficult time, right? So that we have too many people, human population increased like crazy in our previous lecture, right? Like exponential increase, and then we use a lot more this kind of resource in of the earth, right? So that we're going to have a big problem about water shortage problem and air pollution problem, and also the we use too much this kind of air conditioning system in all day. Use those air conditioning use some special kind of working fluid, right? And it's not good for this kind of the earth, right? Create some global warming. So that so that's why, of course, air conditioner gradually, I think in industry gradually try to use more environmentally friendly this kind of liquid, right? The chemical which will not create this kind of CO2 and also the global warming. So this is something so that sometimes all the technology, right? Human create many technology. Sometimes good, sometimes bad. Do you understand? So that 100 years ago, we invent this kind of human invent air conditioning system, right? And that time we don't know. Okay, we use some special chemical, right, to make an air conditioning system working fluid, right? So that we don't know. This kind of thing can really create big trouble for the earth, right? Gradually, we find we have too many air conditioners and generate this kind of big problem for the global warming. So gradually try to use this kind of more eco-friendly material for your air conditioning system. Of course, we'll mention more detail about this issue, right? How this kind of HVAC air conditioner could create big trouble, right? So that in the past many years, people engineer or the industry gradually understand this issue and then try to think about this kind of have a more green building and also green, right? Green this kind of air conditioning system. So this is something and quite important. And of course, water is another quite important issue. So that at this moment, I think there's a large population, a percentage of people in the world has a problem to get the fresh water. Although we have a lot of water in the earth, but still there's a big issue about this kind of shortage of fresh water. I think we have a lot of water in the earth. Here, it should be fresh water, right? You can go to the sea, right? Ocean, but those water you cannot drink. So that, but this fresh water is a big problem in globally, okay? And then of course, another issue is how we use kind of problem of using this kind of fossil fuel, right? If you keep burning of this kind of fossil fuel, oil and coal, and then could generate a lot more pollution, right? So that, and finally, so of course, we want to think about how we can be eco-friendly, right? In terms of use all the material for the building, engineering, design, and construction, right? As mentioned in previous slides, so that this kind of building, right? Globally, building use huge amount of this kind of raw material resources, right? So that the risk can create big trouble. Yeah. Okay, so that you see, as I mentioned, we are not only use the kind of eco-friendly green material, but during the construction, we may also generate a lot more problem. So that those construction, during construction, you see, you generate a lot of this kind of air pollution. So this air pollution is sometimes very bad. So that we'll mention, right? So that once you have a lot of this kind of air pollution, and then so that the worker may cause some disease, right? So that this is something, unfortunately, so that there's some material during the construction may cause some big problem for the health of construction worker. So this is another quite big issue, right? For our this kind of engineer to think about. And then of course, again, so we well, in general, there's a lot more issue we need to consider, right? But in general, I think we want to be first is energy efficient, right? More healthy, and then minimize those problems. Okay, and here I think we also want to highlight this part. So you will surprise that this kind of building engineering globally will consume about 40% of raw material. It's a huge, a big number, 3 billion tons. So this is something quite amazing. It also uses a lot more energy, right? And all this become so critical. That's why globally, almost all the this kind of government in the world, right? Many countries, they try to promote this kind of green building. So it's not only like Hong Kong. Okay, so this, and then so of course, again, so here I think we will not give you a lot more detail about the thing, but in general, so that the key thing here is we need to think about how can we become more and more green building, and then so that in this case, typically, I think there's set up some target, right, for the green building, this kind of initiative, or there's also have certain kind of a green building certificate, right? Typically, the hope the green building design can achieve this kind of energy efficiency, energy saving, about 20 to 50%, and also minimize this kind of CO2 emission, okay, on the order of 30 to 40%. Also reduce this kind of water, this kind of consumption, and solid waste, reduce 70%. So this is something gradually, I think all this kind of industry and the government has certain this kind of requirement, okay? And of course, although the government want to promote green building, like Hong Kong government provide this kind of big money, so that what's the problem of this kind of how you can let more building become green building. What do you think? Hong Kong provided $200 million. Can every building be of in Hong Kong become green building? So this is inbound thing. What do you think? That's a now $200 million Hong Kong dollar. It looks big, but in reality, why do you say how much? No, one building costs, huh? What do you think? So this is still I think it's a very difficult thing to say. Although the government want to push green building, what's the problem? Sometimes, of course, if the building exists for a long time, and then some business owner, right? The owner of the building they are maybe too lazy, or they don't want to spend money to turn traditional building into green building. So that's one of the barrier, right? They say if you don't provide some incentives or something, tax reduction or additional the kind of funding, then I can see that still have some barrier for those kind of to promote the kind of green building. Of course, the good thing is if you have some new ongoing building design and engineering, then all the building design and manufacturing need to get approval, right, from government. Like Hong Kong government need to get approved, right, about your building design and see. So if I think this would be a little bit better, right? So that means for all building, and then you want to turn into the green building, it's still much difficult. But for new building design, then I think it would be much better. So that in general, so that there's a lot more. So that if you can have some way additional funding, right, encourage this kind of green building design engineering, right? Or you set up some special new policy, new building code, right? So that to require in the near future gradually, all the new building need to have a certain kind of a standard to reach this kind of the one which I mentioned in previous slide. You see, so this I can see this will be a little bit much easier for real implementation of this kind of green building requirement. Yeah, of course, as I show you that when you want to have green building, another big problem is a cost issue, right? So that and then compared with traditional building engineering, the cost most likely will increase, right? So that all these are something is non-trivial, I would say. Yeah, and of course, here I think we already showed this one in previous chapter. So basically, so if you look at building as what the building system, right? There's a series of the subsystem inside the building, so that we need in terms of mechanical design, we want to use more green material, eco-friendly material, like what we just mentioned, the kind of fossil. No, not that we just show you this kind of special kind of rock fill concrete, right? And then if you look at energy supply, water supply, and all these things will be quite important for you to think about. How can we come with more green this kind of design, right? And of course, if you look at this kind of solar radiation issue, then what do we think? We may want to think about, can we use this kind of special material for window, maybe smart window, so that it can really take advantage of this solar radiation as way for lighting, and then you minimize the consumption, right? Electricity consumption for traditional lighting, so that I can see that this means we may want to think about how to make the kind of special kind of smart window, some new material, smart, right? It can react to this kind of solar radiation, so that in this case it can be more take advantage of this kind of solar radiation and consume much less this kind of energy, so that this is something I may show you this kind of actually I do have one project about this kind of smart building, and then some I do show you maybe show you some interesting this kind of smart window. Okay, so that thermochromic smart window is one. There are several types of smart window for this kind of using this kind of way, so that let me show you at least one sound intuitive. The smart window is the one has been used in Hong Kong. Okay, let me show you this very simple introduction about this thing. Maybe you can also look at this. Okay, so that let me quickly show you this interesting. Soundtuity is a company. They make this kind of smart window, so you can leverage the kind of solar radiation in more in better way. So that this is something I can show you. This very simple. That means this kind of smart window basically is what? Based on this kind of a solar radiation intensity, they can try to adjust optical property. And then this is not clear. Sorry. I mean, dynamically it can change this kind of optical property based on this kind of material difference, right? Smart material sensitive to this kind of solar radiation, do you understand? And then change the color. And then so that this is something I think is quite a spatial way. So anyway, so this is something quite interesting for you to think about this kind of smart building, right? So that the smart building definitely is something I would say useful. So that it is one government building in Tunmen, government building, they try to install about 10 very large this kind of smart window. So in this case, you see, if you have some smart window, so we can really take advantage of this kind of free energy, right? So that to reduce this kind of energy consumption in the building, including both actually. You can also try to use this kind of solar radiation, replace traditional lighting, and also minimize this kind of energy consumption of air conditioning system. So that this is just tell you this additional example about thing. And how about wind? How about wind energy? What do you think? Actually, some of the tall building, they may also try to use wind energy. For example, if you have some wind turbine, right, in a very tall building, and then actually you can using the tall wind energy to power some maybe electrical appliance inside the building, so that this is something quite useful, right? So that in old day maybe it's difficult, but now with a much more sophisticated wind turbine design, and then so that actually I will show you some example about this thing, right? How some very tall building, they really try to install this kind of wind turbine, right? Thing, right? So that of course you can also think about additional the solar panel, right, to get those energy. So all this will be, I would say, quite solar panel, right? Like to generate get this kind of electricity from this kind of solar radiation. So all this can be quite useful, important. And of course, green building also another issue is once you have output, right? All the output, and then how you can try to minimize this kind of pollution, right? Wastewater, and then seeing heat, and also pollute air and groundwater. So this is also quite important. Some of this one may need to think about a lot more this kind of engineering issue to minimize this kind of pollution problem. Yeah. And of course, here in general, so that all the building, as I mentioned in our previous lecture, we had to consider about subsystem design, right? Our building energy system and our water system, and then air conditioning system, right? And a lot more of building BMS, building management system, so that we need to think about in system engineering point of view to look at this kind how can we come with a green building design and green building engineering and construction. Okay. Okay, so that I think this is something in general we'll mention. I don't think we should talk about a bit too much about this thing, but in general here we can talk about another quite important issue. Why? So when we talk about green building, we need to get some more quantitative way to describe about this kind of green building. What kind of building it can be classified as green building, right? So that is something. Different country and region has different this kind of initiative. In Hong Kong, the government promote the kind of being plus, right? So that but the other part of the world, like in United States, you can see they have some other organization have California Green Building Code and USV, right? So different part of the world, they have different way for this kind of green building certificate, right? And those kind of standard. So, okay. And I think I can also share with you about this. In Hong Kong, we have our own this kind of government requirement and suggestion. So that here I show you. In Hong Kong, actually there's one NGO try to promote this kind of green building and also this kind of, we call this Being Plus, okay, from the Hong Kong Green Building Council. Okay, so it's an NGO, non-profit organization, and then bridge between the Hong Kong government and industry to promote this kind of certification. All right, so when you try to look at this kind of green building design, so that definitely it's important to come with it's good. This is very good. Now you have some kind of standard or this industrial or general guideline for you to think about this kind of a green building design. Yeah. So I think also quite useful for you to look at for Hong Kong government point of view or Hong Kong this kind of point of view. What's the typical
now.
Okay, so this give you a little more introduction because at least here we are in Hong Kong, right? So that I think it's quite important for you to at least understand about this from this Hong Kong point of view, right? What's the typical the certification, right? So that this being plus is the one. Of course, there's the other this kind of green building certification system. So that and of course. LEED is another, I think, quite common. This kind of a green building rating system globally. So that in this case, I think even in Hong Kong, some this kind of big industry will also want to look at this kind of LEED, this kind of system to promote. Why? Because at least internationally, this one has been used actually by a lot more. This in people and industry. Okay, and of course there's another issue, right, for green building. As I mentioned, so that there's another quite important issue for this, how you can pick up the right place, right, for the building engineering. If you can pick up the good place, and then so that in this case you may save energy. For example, if this kind of you choose some area which is close to, for example, in Hong Kong, MTR, so that in the case, people inside the building can easily, right, take this kind of public transportation system, so that this can be really save energy, right, and also reduce this kind of CO2 emission. If you are very far from this kind of public transportation, this kind of service area, then you most likely either have to take a taxi or drive a car. So this is something quite important, right? So that and then of course one additional aspect is when you think about this building engineering. So what's the other issue? We need to think about additional stormwater issue. So that this is another aspect of thing, especially once you have a rain or a big rain, and then so that stormwater may cause some big problem for additional pollution. And one additional thing is once you have a building and near this kind of maybe the mountain or thing or other things, so that we also make sure that you can minimize the impact of the building engineering on the wild animal. So this is something and quite important thing. People say that we got a lot more this kind of virus, right? Like SARS has come from human try to create a lot more the kind of building or something, so that occupy those wild animals the space in the earth. So then those kind of virus or bacteria will spread from this kind of animal to human. So this is something is a quite important issue, right? So if you try to use a lot more this kind of land which you originated for those wild animal, then that can be quite dangerous. I think there's a certain kind of a very dangerous infectious disease is really that human try to we try to grab a lot more land, right? Fight with those wild animal, and then eventually those animal has certain kind of virus or a bacteria, and really creates big trouble. Okay. I don't know if you still remember like SARS. What do you think? In 2003, Hong Kong, we do have SARS. At that time, we have almost 300 people die. So that, of course, I know that people, those medical experts have been studied to see if this is something related to those kind of animal, like those kind of pathogen, those virus, and then some virus in the animal can be transmit to the human. Some virus in the animal will not. So this is something I do think some of this kind of we are going to have a lot more this kind of infectious disease, right? So that this is something green building is also something we important how can we human can live more harmonious with the other this kind of animal in the world. Why? So that in this case, if we continue to fight this kind of more space and more land, and then eventually we got big trouble. At this moment, you can see this kind of COVID-19, how many people die? Huh? How many got this kind of virus, and then we create a big trouble. So this is, from my point of view, is something green building is not only we take care about how to save energy and cheaper and create less pollution problem, but it's another important issue I would say is how green building can be we can live more harmoniously with those kind of the other wild animal or something, so that will not create some big trouble, right? So that this is something I can see is quite important now, yeah. And of course, so there's another issue is you see, if we have this kind of choose proper this kind of location, right, for the building engineering design and construction, and then in this case we can also minimize some problem. For example, this kind of soil erosion and a lot more stormwater runoff. So this is another issue in terms of engineering issue, yeah. And one additional thing is when we look at this kind of selection of this kind of location for, so this kind of building engineering design, so that first, of course, we may need to make sure that we pick we avoid some of this kind of area which is you see, farmland sensitive habitat. That means those area for wild animal. And then of course there's another thing is if we have a building, too many building in a big city, what's the problem? Too many building can create a heat island effect. That means we can create a lot more, now become much hotter. Do you understand? Once there's so many buildings put together, and then so that can create some big trouble. Why? So the many times, I think in recent year, many this kind of big city have suffered this kind of heat island effect. So what is heat island effect? Oh, I think here there's a one interesting video, video. Basically, it's once a lot of building, right, and then solar radiation, the sun give you heat up all the building, right, and then in this case you can locally you have a lot more this kind of heat accumulate for in so many building, and then you change this kind of this kind of a wind circulation, and then so create this kind of big problem. Up here, I think this is a good.
Heat is the #1 weather-related killer in the United States. During extreme heat events, urban areas are at a higher risk for impacts. The physical makeup of cities causes their temperatures to be hotter than their surroundings, a phenomenon known as the urban heat island effect. During the day, the sun can warm buildings, streets, roofs, and cars 50 degrees or more hotter than the air around them. Unlike their rural counterparts, the building's materials are dry, limiting evaporative cooling. Plus, at night, these materials release heat at a much slower rate. On average, a city with 1 million people or more runs about 2 to 5 degrees hotter than its surrounding area.
Right, so this gives you some quite important message, right? So that for big city, right, we have a lot more building in Hong Kong. I told you, and then about more than 40,000 building in the private sector, and then so that so especially in the summer, we have a lot more solar radiation. Those kind of solar energy were absorbed by this building. Do you understand? And then so that in this case, during the nighttime, so that you see this kind of release this kind of solar energy, right, inside the building out, so that you see you feel much hotter. So this can be sometimes it's a very difficult, right? And then in this case, it becomes the worse. So you the hotter, and then you will use a lot more this kind of air conditioning system. You consume more energy. So this become, I think, one of the big issue. So what do you think? Can we really minimize this kind of a problem, heat island effect? What do you think? How to avoid this kind of this kind of problem? This is we're engineer. If you understand this kind of basic, this kind of phenomena, right? Basically, the heat island effect is the solar radiation well, right? Will hit on the building, right? So that so how can we minimize this kind of problem? Of course, the problem is not one. You have too many building, and then so that so all the building question. So I don't know. Do you have any idea how to? Oh, we have some student already described. Good. We have several students. One student mentioned how we can maybe decrease the density of building, right? And then of course green rooftop. Okay, very good. So that if you have some additional green this kind of plant on the top of the building, so then we can try to use, because all the green this kind of plant, right? There was absorb solar radiation for what? Photosynthesis, right? All the green plant, they have to absorb this kind of thing, so that in this case it's quite important, so that this kind once you have a green this kind of a plant on the rooftop, so that you can really try to minimize this kind of heat island effect. Okay, but of course if you for traditional building, if you want to have green rooftop, so that you also be very careful. This kind of green will be good, right, for green building, right, to avoid this kind of problem, right? But there's another problem. There's no free lunch. You create some green rooftop. I don't know. Do you have any idea what's the problem? For engineer, there's no free lunch. Very good. We have increased the kind of loading. Yeah, we have students also mentioned increase the kind of loading, and then sometimes one student Paul Yang mentioned it may cause some structural risk. I do remember there's one building. Is that CTU? The building actually collapsed doing that. So that if you want to turn traditional building into the green building with additional green plant on the rooftop, so that that's definitely you need to think about how to do this kind of renovation of the building design. You will not create some big trouble, right? Because original if you have an original building design, doesn't consider about this kind of additional loading, green plant loading effect, and then with additional like a rainfall, right? A big like a water, rain, and then all the water going to this kind of rooftop, and then a big problem, right? So this is something become quite big issue. Oh, once, yeah, I remember it should be CTU, right? One CTU, they do have green building initially, and then unfortunately the collapse. So the so this is something is non-trivial to think about this issue. So that although a green building is good, but again, there's no free lunch. So that so this is quite important thing. I just think that this is something important. Several years ago, we do have this kind of a problem happen, and then so that I just tell you, there's no free lunch. So if you want to improve this kind of performance of something, and then the other, you need to be careful. Otherwise, you may create some big trouble for the building. Here, I show you. We have one example. CTU, right? They do have this kind of green building, and then they collapse during that. So this is something I just tell you. This is from engineering point of view. We promote, why we push something in one aspect. Oh, I want to increase this kind of a green building, and then, but if I forgot about the other issue, mechanical strength issue, and then especially then you can create this kind of trouble. So I tell you, this is something a good example for all of you to think about, right? So that there's no free lunch. No thing. The same thing we mentioned. Air conditioning system is very good, but the air conditioning can create some environmental problem. Why? Global warming. Most likely, people say global warming is due to a human use too much air conditioning system, and in the air conditioning we use those kind of special working fluid liquid, will create some big problem. Why? And then so this is something is quite important for all of you to think about here. And of course, as here I show you some typical example why the heat island effect. So that you see, if you have too high density of this kind of building, and then density too high, and then so that the temperature, so there's a difference, right? The temperature will be higher than the other area, which is maybe rural countryside. So that's something is clear, show you the important issue of this kind of green building issue. Okay, so a non-green is a heat island design issue. Okay, so that anyway, so that show you, so that the key thing here is that we need to think about how can we solve the problem, right? So that what we talk about here, so that this definitely, this is one solution. There's no problem, right? And then of course another thing is maybe install some of reflective, this kind of coating or something, so that you can reflect this kind of solar radiation, right? And one more, as I mentioned, you may also look at, I'll show you kind of smart window. Smart window, we can leverage what adjust the optical transmission efficiency of this kind of window, so that selectively let this solar radiation pass through. Some of them we try to now reflect doing that. So this is something definitely is a quite useful way to think about in terms of green building design, right? To minimize heat island effect. I can also give you some reference about the project. I try to work with MIT, and I discovered that the Hong Kong government do have this kind of initiative, and one government building do use this kind of smart window to enhance this kind of. I can share with you about this kind of sound intuitive, this kind of comparison for you to look at. Is this kind of useful for typical things? This is typically is important for you to think about this kind of how can we come with more this kind of green building design, right? So that definitely this kind of smart window is a possible way to come with better design. I will share with you about this kind of study I have done several years ago when I project with MIT, so that I will try to upload this particular sound intuitive smart window, right? And how this kind of a smart window can be useful, right? Again, minimize this kind of energy consumption for air conditioning, and also take advantage of kind of solar radiation, right? To minimize this kind of traditional lighting inside the building. So that this is something quite important. Definitely, again, there's no free lunch. This smart building is what? Much more expensive, right? So that in this case, but I think it's at least 4 times more expensive compared with traditional those window. Okay, so that but in this case, if you look at this, how you can save energy, right? And then so that's really important thing to find some they can say ROI, this kind of thing to think about, can this be useful, right, in long term, save energy, so that, and also minimize the kind of problem of this kind of global warming problem. So definitely I just say this is something is important. Engineer need to find some balance of this thing. Okay. And of course, if a green building design is okay, if you location of the building close to this public transportation system like MTR and RC, then you definitely can also reduce the kind of energy efficient energy consumption. Okay. And one additional thing is we almost run out of time, so it's a stormwater problem. So that, what is stormwater? Stormwater typically is especially when we have, of course, we must have some raining, right? Some rain, and then a rain will hit on the building, the surface of the building, right? And then in this case, and then this water will go down to like on the ground, and then what happened? This ground maybe cause some problem. Especially what we care is you can cause some pollution. Do that? You try to pollution, and then this is one big issue. How can we think about this kind of a groundwater pollution problem? So this is definitely is one of a big issue. So that and then once you have this kind of stormwater thing, and then so you can really call it some water pollution. Okay, degradation of this kind of those foundation near this kind of building. So there's a series of issue for this kind of stormwater issue. Okay, so I think we almost run out of time today. Again, today we try to focus on this kind of green building, and really selected this kind of concept, and also show you some example about green building. But of course, as I show you, at the end of the day, is so there's no free lunch. You say when you push certain kind of this kind of green building engineering, and then so we do need to find make sure that the other aspect of building engineering design is okay. So that this is a I think quite important issue. Again, so do you have any question or comment for today's lecture? Definitely, I would say this example of CTU is one good example. Right? So green building is good, but green building you need to think about more. Right? You may need to have certain renovation of the building design. Make sure you will not create some this kind of collapse of building, and then may kill a lot more people. So this is one of the important issue for our engineer, to find some balance about all the important this kind of building performance, why efficiency, why this kind of pollution issue, and also other thing, why environmental friendly, and then eco-friendly this material. I think we run out of time, so if there's additional question, please free to ask a question on our campus website. So again, I do hope that you can try to ask questions, so that this will be important as I give you additional bonus point. Okay, so again, if you have time, you are welcome to attend this kind of a special seminar. This definitely is related to this kind of green building engineering, how we can save this kind of